Hello class, in this video we will be talking about motion in two dimensions. For two-dimensional motion, the path of an object can be represented with three vectors. One vector shows the straight line path between the initial and final points of the motion. One vector shows the horizontal component of the motion, and one vector shows the vertical component of the motion. One of the example of a two-dimensional motion is what we call a projectile motion, which is the movement of a body in a parabolic path with horizontal and vertical components. Projectile motion follows a path of projectile, and that is what we call trajectory. So when you ignore the effect of air resistance, the projectile is in the state of free fall because its path is determined entirely by gravity. So according to Aristotle, initial impetus is applied to an object making it move into a new region. But according to Galileo, a projectile moves in constant horizontal motion simultaneously with a constant vertical acceleration, and this results in the parabolic path of the motion of the projectile. And this figure here shows the trajectory path of a ball with an initial velocity of v sub 0 at an angle of projection theta with the horizontal. The vertical velocity or v sub y of this ball from this position is equal to initial velocity times the sine of the angle. And our horizontal velocity or our v sub x is equal to v sub 0 cosine of the angle. And at the maximum point of the ball, it reaches our vertical velocity or v sub y is equal to 0, while our horizontal velocity is equal to v sub 0 cosine times cosine of the angle. And to the final position that the ball reaches, our v sub x or our velocity in horizontal is equal to v sub 0 cosine of the angle, and our vertical velocity would be equal to v sub 0 sine of the angle. So the distance from the initial position of the ball to the final position of the ball after its flight is equal to the range, or what we call the range. How are we going to get the range? So range, or R, is equal to v sub 0 and x, or the initial velocity in our horizontal, times t, capital letter T, equal to 2 times t, or t, capital letter T, is our total time of flight, which is also equal to 2 times t. So from this position, initial position, to our maximum position, that is small t, and from the maximum position to our final position, that is another time of flight. So the final total time, let's just add the time from the initial position to the maximum position plus the maximum position to the final position, the time it took to travel, and that is what we call our total time of flight. So time is equal to 2 times the smaller t. The horizontal and vertical components of projectile motion can be calculated by the following equation. For acceleration, our horizontal acceleration is equal to 0, and our vertical acceleration is equal to our negative gravity. Remember the value of our gravity, which is 9.8 meters per second squared. Our horizontal velocity is equal to initial velocity times the cosine theta. Our final velocity in the horizontal is equal to the initial velocity in x. And our velocity in the vertical component is equal to initial velocity times the sine of the angle. Or our final velocity in our vertical is equal to v sub 0 minus acceleration in our vertical in y times the time it took to travel. And for our displacement, we can use this formula. Displacement in horizontal is equal to the velocity in horizontal times the time. For vertical component, we can get the displacement is equal to the initial velocity in vertical in y times t plus 1/2 acceleration in y times t squared. Or we can manipulate this equation. We'll have 2 times acceleration in y times displacement in y is equal to velocity in y squared minus initial velocity in y squared. So there are things to remember in solving for problems in two-dimensional motion. At any instance, the velocity of a projectile is inverse tangent of v sub y divided by v sub x with the horizontal. So the acceleration is equal to the acceleration due to gravity. At the highest point of trajectory of the projectile, only the vertical velocity is equal to 0, but our horizontal velocity has a value. Therefore, the velocity of the projectile at its maximum height is equal to its horizontal velocity. So since the motion along horizontal is uniform, the horizontal velocity is constant and is equal to the initial velocity. So when the people returns to the same level, its launching point, it moves down with a speed equal to its initial speed. So the time it takes to go up to its maximum height is equal to the time it takes to go down from its maximum height to the same level as its launching point. For example, a football is kicked with a velocity of 20 meters per second at an angle of 30 degrees with a horizontal. Find letter A, the horizontal and vertical components of its initial velocity. B, the time it took to reach its maximum height. Letter C, the time of flight. Letter D, the maximum height it reached. And letter E, the range it traveled. So let's start with letter A. Let's find the horizontal and vertical component of its initial velocity. Final velocity is equal to the square root of the final velocity in x squared plus the final velocity in y squared at an angle of, okay, letter A, we are asked to get our initial velocities in our horizontal and our initial velocity in our y. So recalling the given, we have our initial velocity is equal to 20 meters per second and our angle is equal to 30 degrees. So to get our initial velocity in x, recall that is equal to our initial velocity times the cosine of our angle. So just substitute the value. Initial velocity is 20 meters per second times the cosine of our angle, which is 30 degrees. And we will have, using your calculator, we'll have 17.3 meters per second in that is our initial velocity in our horizontal. For our initial velocity in our vertical, we'll have initial velocity times the sine of the angle. Substitute the value, that is 20 meters per second times the sine of the angle, that is 30, and you will have our initial velocity in y is equal to 10.0 meters per second using your calculator. And this is our initial velocity in our horizontal and vertical components. For letter B, the time it took to reach its maximum height. Okay, for letter B, what is asked is the time it reached its maximum height. So we are to get our time. So to get that, let T be our time that the ball it took before reaching the maximum height. So to find this, let's consider only the vertical component of the motion. You have to recall that over here, if the ball is from here to its maximum height, this is our t. And you have to recall that at maximum point, our v sub y is equal to 0. Therefore, our time is equal to the v sub y minus our initial velocity in y over our acceleration in y. Thus, we can calculate, we know that v sub y is equal to 0 minus our initial velocity in y is, from letter A, we know that, this is from letter A, we know our initial velocity in y is equal to 10 meters per second, if you could remember. So let's just substitute this value. That is 10 meters per second over our acceleration in y. You have to recall that our A will now be equal to our negative gravity, therefore negative 9.8 meters per second squared. Calculating it using your calculator, you will have 1.02 seconds. So our t is equal to, or the time that the ball took before reaching the maximum height from the initial position is equal to 1.02 seconds. For letter C, the time of flight. Therefore, for letter C, we are asked with the time of flight of the ball from the initial position to its final position. So to get that, we know that we are asked with the time of flight. If you could recall how to get the time of flight, we know that t is equal to 2 times the small t. And we know that from letter B, our time is equal to 1.02 seconds. Substituting the values, 2 times 1.02 second is equal to 2.04 second. And this is the total time of flight of the football from the initial position to the final position. Letter D, the maximum height it reached. Okay, for letter D, we are asked with what is the maximum height of the ball that it reaches upon its takeoff, or the maximum height can be equal to our distance sub y. So we can use the formula 2ay times our displacement in y is equal to our final velocity in our y squared minus initial velocity in y squared. So let's manipulate the equation. You divide both sides by 2 times its acceleration. So you will have 2 times acceleration divided by 2 times acceleration is equal to 1. So we are left with dy is equal to v in y squared minus v initial y squared over 2 times acceleration in y. So we know that our acceleration in y is equal to 0. Let's just substitute that here. 0 squared minus our initial velocity in y is 10 meters per second. This is quantity squared over 2 times acceleration. We know that our acceleration in a projectile motion is equal to the negative gravity. So our value for our gravity is negative 9.8 meters per second squared. And hence, using your calculator, you will be left with 10 meters per second. Quantity squared is 100 meters squared per second squared over 2 times negative 9.8 meters per second squared is 19.6 meters per second squared. Manipulating this one, we are left with 100 divided 19.6 is 5.10 meters. Hence, the maximum height of the ball it reaches from the initial position to the final position is equal to 5.10 meters. Letter E, the range it traveled. You're asked to get the range. How can we identify the range? You have to recall, if this is the initial point, this is the maximum point, and this is the final point, our range is this one. If this one is our dy, this is our range. How are we going to get that? Recall that range is equal to the initial velocity in x times our total time of travel. We know that our initial velocity in x from letter A solution is equal to 17.3 meters per second, and our total time of travel, letter T, is 2.04 seconds. Let's just substitute all these values. That's 17.3 meters per second times our time, which is 2.04 seconds. Using your calculator, you will get that our range is equal to 35.292 meters, and that is approximately 35.3 meters. And this is the distance from the initial position to the final position, or what we call our range. I hope you have learned from our lesson today. Thank you for watching, and goodbye.